Hey everyone, welcome to the third video in our series on the reactions of chapter 10. So in the last two videos, we've been talking about different reagents, right? So in the very first video, we talked about Grignard reagents. In the video after that, we talked about organolithium reagents. In this video, we're going to be talking about something that is similar to organolithium reagents, and that is a Gilman reagent, all right? So Gilman reagents. Okay, so Gilman reagents are also known as lithium dialkyl cuprate reagents. Okay, so a lithium dialkyl cuprate. All right. Okay, so let's first talk about formation. So how do I make a lithium dialkyl cuprate? So start off with this 3-carbon organolithium. All right, I'm going to use two equivalents of this, and I'm going to put that in with CuI. So copper and iodine bonded together, right? And what happens is this copper rather, gets bonded to the alkyl group twice. So I have 1, 2, 3, 1, 2, 3. So my alkyl group is 3 carbons, right? So I have two equivalents of that, so it's going to get bonded to that twice, which is going to give that a negative charge. So the lithium is there to counterbalance that charge with a positive, okay? So this is a lithium dialkyl, because I have two alkyl groups, cuprate. Cuprate means copper, all right? So lithium dialkyl cuprate. So that is what I'm making, but the way that it's typically written is like this. So what's in parentheses? It just means that whatever's in parentheses, there's two of those. So I have two of these 3-carbon groups connected to copper, all right? So I'm going to write it like that because that is the correct way to write it. So this is what I've actually made, okay? So that's it, all right? So the other way to do this is I can start off with an alkyl halide. So let me start off with, I don't know, this alkyl halide, I guess. And if I put this with two equivalents of lithium, followed up by CuI, then this two equivalents of lithium is going to turn this into a organolithium, right? It's going to turn this into a lithium compound. So organolithium is then able to react with CuI to give me my lithium dialkyl cuprate. So all I need to do is take my two groups here, or my group, and then bond it to CuI, and then there's just going to be two of those. Okay, so I can also alternatively start off with alkyl halide, put in two equivalents of lithium, and then put in CuI, and then boom, I have my lithium dialkyl cuprate. All right. So these are the two ways that I can do it. So this is formation of lithium dialkyl cuprates. And it doesn't have to be like this. It doesn't have to be alkanes. It can be really anything. It can be kind of a lot going on sometimes. But yeah, it can be anything. So let's start off with this one instead. And then again, first step, just two equivalents of Li. Second step, CuI. And then all I'm going to do is just make two of these bonded to a CuI. And that's it. Okay, so that's how I make Gilman reagents. All right, so now let's talk about reactions of Gilman reagents. Gilman reagents can do two things. All right, so the first thing is they can add to acid chlorides. All right, there are many other things that Gilman reagents can do, but we're just going to worry about these two. All right, they can also do like 1,4 additions to alpha beta unsaturated ketones and stuff, but we're not going to worry about that. Okay, we're just worried about the acid chloride reaction, and we're just worried about another reaction that they can do. Okay, so lithium dialkyl cuprates are a little bit less reactive than Grignards and organolithiums. So if I have a lithium dialkyl cuprate. So let's just start off with this one that I have over here. And I put in some acid chloride in THF. Then what's going to happen is this chlorine is just going to get replaced by whatever this is. So I have 3 carbons. That's just going to replace the chlorine. 1, 2, 3. And it stays as a ketone. Okay. So typically we'd been seeing these in the last 2 videos. We've seen these acid chlorides becoming 3-degree alcohols with Grignards and organolithiums. In this case, with Gilman reagents, they do not become 3-degree alcohols, right? Acid chlorides actually become ketones, okay? So that's an important distinction to make. So acid chlorides become ketones, right? So the carbonyl group stays. It does not become an alcohol in this case, all right? So that's definitely important. And so the other thing to say that is that really only acid chlorides are going to react with this. So if I have something that has an acid chloride and an ester in it, I'm not really going to be getting a reaction, okay? So we'll have a long one here. So then if I put this through with something that has an ester and an acid chloride in it, so if I have an acid chloride on one side and an ester on the other side. So remember that esters and acid chlorides for organolithiums and Grignards both were reactive, but in this case, this ester is not going to do anything, like at all. So this ester is just going to stay the way it is. So let me write that. Ester stays the way it is. Then I have this. Then I form this ketone on the other side, right? And this is 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. So that's what I get. Okay, so the ester doesn't do anything, and then I just form a ketone with that acid chloride. All right. So this is one reaction that I can do. Okay, so I can react a Gilman reagent with an acid chloride. That's one possibility. Okay. There is another possibility. So let's take a look at this. So Gilman reagents can also do SN2. All right, so I know we love SN2. So what I'm going to do is I'm going to start off with some alkyl halide. Or, excuse me, sorry. We'll start off with the Grignard first, actually. Change my mind. So we'll start off with this, or not a Grignard, Gilman, sorry. Jeez. So we'll start with this Gilman, and what we're going to do is we're just going to put in a good SN2 substrate. So in this case, this is a fantastic SN2 substrate, right? This is 3 carbons, and this is 3 carbons. So I'm just going to react something that's 3 carbons with something else that's 3 carbons, so I get 6 carbons. So this is my product, okay? So it's just hexane, right? So all that's happening is an SN2 reaction here, and like this bond is attaching to this carbon, and then the bromine leaves. So that's all that's happening. There is a mechanism for this, but it's strange. We're not going to worry about it too much. I could write like a simplified, like hypothetical mechanism, but I'm not going to do that. So let's take a look at another example here. In this case, we're going to have a ring. So in this case, we're going to do SN2 again. Okay. And, oh, I don't know. We'll do SN2 on this, I guess. So now all I'm going to do is just replace this chlorine with this cyclohexane. That's it. I'm done. It's easy, right? That's all we have to do. And I can also start off with I can start off with an alkyl halide. Okay, so let's say I start off with this alkyl halide. So I can start off with this, and I can add in my 2 equivalents of lithium. And then as a second step, I can add in CUI. And then as a very final step, I can add in some alkyl halide. So let's add in this alkyl halide here. Okay, so this first step is going to replace the bromine with a lithium. The second step is going to turn this into a Gilman reagent, and then the third step is just SN2. All right. So all I do is replace the chlorine with my Gilman. So I'm going to take the chlorine where the chlorine was, and then I'm just going to replace it with 1, 2, 3, 4, 5 carbons. So then I have the double bond there. Okay. So all I did was this bromine was going to turn into a lithium, which would then turn into a Gilman reagent with CUI. So then I'm just taking where this bromine was and where this chlorine was and just drawing a bond between them basically. All right, so I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then a methyl group there. All right. So these are the two things I can do, right? I can do addition to an acid chloride, or I can also do SN2 reactions. Again, there are other things that Gilmans can do, but for our intents and purposes, these are the two that we're concerned about, okay? And like I said, mechanism-wise, we're not going to worry about it too much. Just no real point, all right? So hopefully this was helpful, and I appreciate you watching. And I will see you in the next one for the very last video. So hopefully you'll tune in for that one.